So, welcome everybody again to another edition of Webinar Wednesday. Today we have a topic that is going to appeal to a pretty wide variety of people. If you are on the BNI, business and industry side, or the workforce development side of our community or technical colleges, if you have a role like that with our universities, if you are a manufacturing executive, if you are a workforce investment board, anybody in any of those types of endeavors is going to really want to listen to what we have to say and what we have to talk about today as we dive into this topic of what is that one thing that will make you a better manufacturing executive. You know, as somebody who worked in manufacturing for quite a number of years in executive roles, we always were looking for that one thing that would make us better. I like to tell the story of how I took my first role in senior leadership in manufacturing, and it was with a radio frequency identification company, a high-tech company. We were building out and designing and innovating solutions primarily for the healthcare industry. And so I was actually, as someone who did not come to the world of manufacturing through a STEM discipline, I was actually the controller of a manufacturing of a high-tech RFID company. And the truth is the company was struggling a little bit. And I came into work one morning. I had only been there for about 4 or 5 months in my role there. And I found out that the president of the company had been fired by the board of directors. And I found out that the vice president of the company had been fired by the board of directors. I literally started that day at work without a boss. And it was a couple hours into the day that the phone on my desk rang. And I picked it up, and it was the chairman of the board of a company, an investment banker who worked downtown. We were kind of out in the suburbs. And he said that he needed to see me in his office later that morning. So I knew what was coming, right? Company wasn't performing. President and vice president had just been terminated. And so I packed up the things in my office and kind of organized things, took a walk around the plant and just smiled and chatted with a couple of the people. Didn't let any of them know that I thought I was being terminated, but just wanted one last walk through that facility. So I got in my car in the parking lot and I drove the 30 minutes or so downtown into this big investment bank, walked into the lobby, sat down in a big leather chair surrounded by mahogany walls and books, just an absolutely beautiful office. And a while later, the chairman of the board of that company came out and greeted me and then walked me back to his office and sat me down. And I prepared myself for what was coming. And he said, we're really disappointed in the performance of this business. And I said, I know. And he said, we need to make some changes. And I said, I know. And he said, we fired the president and vice president. I said, yes, I heard that. And then he looked at me and he said, we're going to need someone to run the company. Do you think you are up to it? Of course, I wasn't up to it, but there's only one right answer to that question. So I accepted the challenge. But I can tell you that I spent the next year looking for that one thing that would make me a better manufacturing executive. The truth is, I knew a lot less about running a company than I thought I did. And I would spend time poring over books and getting my hands on any resource that I could to help learn about how to be a better manufacturing executive. So there isn't one golden rule. There isn't one golden solution to that question. I can tell you that from experience. There isn't any one thing that will automatically make us really, really good. It's a series of steps. But the one thing we are going to talk about today is something that I wish I would have known and I wish I would have done over 20 years ago. Let's start with this. I was looking at some research this week that was published by Boston University. It was actually based on a study that was done by the Harvard Business Review. And this is what that study found. It found that 34 of the top 100 performing global CEOs had this in common. 34, over 1 in 3 of the top performing global CEOs, believe it or not, have engineering degrees, according to the Harvard Business Review, according to Boston University. Now, that's an interesting statistic in and of itself, right? For anybody who's studying manufacturing engineering, industrial engineering, anybody who is in a electrical engineering program, a mechanical engineering program, 1 in 3 of the top performing global CEOs have engineering degrees. And that means that the opportunities are wide open for anybody who is studying engineering. Now, that's an interesting observation in and of itself, but it's actually not the reason that I bring up this statistic. If 34 of the top 100 performing global CEOs have engineering degrees. If 34% of the top 100 top performing global CEOs have degrees in engineering, what else does that mean? What that means is that 66% of the top performing global CEOs do not. And I would tell you from experience that probably close to that many CEOs and leaders of manufacturing companies do not have backgrounds in technology, do not necessarily have backgrounds in engineering. They came to those types of roles through a whole variety of different pathways. Maybe they found their way to that type of a role through going to business school and earning an MBA or having an undergrad in business or a related discipline like accounting or finance or marketing. Maybe they studied communications. I can tell you that one of the most interesting top executives of a manufacturing company that I met in the last 12 months actually had a degree in an undergraduate degree in music, proving that you can find your way to success in manufacturing. You can find your way to leadership in manufacturing through a whole variety of disciplines. And I have interviewed tremendous numbers of people for roles in manufacturing that had engineering degrees and tremendous amount of people, numbers of people who did not. And so interviewing for people in roles like plant manager or general manager or vice president of operations or sales supervisor or shop floor supervisor, operations director, interviewing people for jobs like these was something that I did for decades and decades. We're also in kind of an interview mode this week here at ATS Lab Midwest. We're adding people on the business development side, both in Wisconsin and in Michigan, on the industrial side of our business, on the education side of our business. So I've been from one interview to the next, virtual interview, phone interview to the next all week long for several weeks. So I'm kind of in an interview mode. I actually enjoy interviewing. I enjoy meeting people and getting to know what makes them tick. Now, for those of you who are wondering, what does anything about this have to do with that one thing that will make somebody a successful manufacturing executive? Be patient. I get the whole half hour this week. We don't have a guest. And so we have time to get to the answer to that question, and we are getting there. But know that I love really, really interesting interview questions. If I interview somebody, don't expect a question like, what are your strengths or what are your weaknesses or what are your goals in 5 years? Every single interview candidate knows that question is coming. Every single one of them is prepared for that question. That is not the way that I like to interview. I like asking deep questions. Like if you had one moral dilemma over the course of the last 10 years that was the toughest dilemma for you in business, what was it? And how did you think about it? And how did you get to the conclusion that you got to? I like to ask questions like, who is your boss or your supervisor in your latest role? What did you like about that person? What did you not like about that person? If I asked that person, what is one thing they didn't like about you? What would they tell me? What would they change about you? What would you change about them? I like asking questions like, if your telephone went off at 3 in the morning, and it was your third shift supervisor calling, telling you that you had a line down for an order that needed to ship by noon that day. The production line was down. What are the first 5 things that you would think about as you were going about solving that problem at 3 in the morning? Those are the kinds of interview questions that I like to ask. But, thinking about this idea that 2/3 of industrial executives, 2/3 of the top performing global executives come from disciplines other than engineering, I'd like to share with you some other questions that if I had to do it over again, I would ask of people who were candidates for positions in my manufacturing operations if they were looking at being part of our senior leadership team. Let's try these on for size. How about what is a point-to-point Ethernet network? In this world of advanced manufacturing technology where control systems are becoming more and more important, where transferring information and controlling our manufacturing operations autonomously is becoming more and more important, what is a basic thing like a point-to-point Ethernet network? Do you know what that is? I might ask a candidate for a senior executive position in operations, what is a variable frequency drive? Motor control is at the very basic level of running a manufacturing operation. Electric motors are ubiquitous in manufacturing. What does a VFD do? And how would you use it? How about this question? I might ask, what is a directional control valve? And what does that do? DCVs are obviously important parts of fluid power systems. Fluid power like hydraulics and pneumatics, that technology is all over manufacturing floors. What is a directional control valve? Why is it important? And what does it do? Do you really know fluid power, or do you just pretend to and talk about it? Things like precision measurement, things like tighter and tighter tolerances, those are becoming more and more likely to be encountered in the world of advanced manufacturing. I might ask a candidate for, yes, a senior executive role, what is a dial caliper and when would you use it? Do you know how to read it? Here's a dial caliper. Can you show me how you would use it? How about number 5? What is the difference between and, or, not, nor, NAND, and memory, and why do they matter? Control logic, again, is at the basis of almost every single manufacturing operation. And these types of commands and programming using these commands is table stakes for manufacturing operations. Does a candidate for a senior executive role in the operation of an advanced manufacturing company know what and, or, not, nor, NAND, and memory are? And do they know why they matter? Let's try number 6. Industrial robotics, automation, all of us know that these are becoming more and more common in manufacturing operations. And as we move into the future, we will see more and more types of robots and more applications for robotic technology in logistics, in painting, in welding, in assembly, in material handling. What are the 4 types of industrial robots? I might ask someone who's a candidate for an operations role. I have 10 of these, so we have a few to go. Number 7, what are a datum and a datum feature? I can tell you that in manufacturing, people handed me drawings all the time. And I could get away with looking at them and getting an idea of what the part looked like. I even got pretty good at being able to look at the dimensions and being able to determine the weight of a part just based upon the base material and the dimensions of that part. So that's important. But I might ask somebody, what are a datum and a data feature? A datum feature. What is a title block? How do we gather the information from that title block or a material specification? And what do we do with that information once we have it? Does that candidate for a senior executive role really understand how to read a drawing, or are they just pretending to? How about describing the difference between current, voltage, and resistance? This is just basic electrical technology. Seems to me that just about everybody in a senior executive role should be able to explain to us what current, voltage, and resistance are. 2 to go. Number 9, what is I/O? We all know that programmable logic controllers are the computers that run manufacturing operations. At least many of us know that. But what is I/O? What is discrete I/O? What is digital I/O? How are they different? Does somebody really know what a PLC does? Or do they just talk about what a PLC is? And finally, number 10, what does a solenoid do? I can tell you, I heard that word all the time when I was running manufacturing companies. I kind of knew what a solenoid did, but I didn't really know what a solenoid did. Now I do. And we're going to talk today about how I learned it and how I learned these other 9 things and why it's important for a manufacturing executive to know these things. So these are the types of questions that I might add, maybe not all of them, but some of them, to an interview of somebody who is interviewing for a position in one of our manufacturing companies if they wanted to be in a position of vice president of operations or senior director of operations or industrial engineer. I might want to know, do they really know the base technology that we see all over manufacturing operations? Now, is it absolutely necessary? Is it critical that somebody know all these things in order to be successful in manufacturing? The answer to that question is no. And the truth of the matter is that I feel like I had a fairly successful manufacturing career, ran several manufacturing companies, sold and bought several manufacturing companies over 20 plus years in manufacturing. I knew what some of this stuff was, but I didn't really know what it was. I didn't know the details. I didn't know how it worked. I didn't speak the language. I could speak it well enough to be able to get away with it. I heard somewhere that you don't have to know everything about something in order to be able to use it. And I like to think that my career and many other people's careers are based on that. We don't need to be experts on all of this in order to be able to use it. But it doesn't mean that being experts in these things isn't important. I believe that manufacturing executives that have a detailed understanding of base manufacturing technology improve themselves in 3 ways. And there are 3 ways, all that begin with the letter C. The first one is credibility. When we can speak the language of manufacturing, we have more credibility with all of our customers. If a customer knows that we know base manufacturing technology, they will have more confidence in our ability to be able to execute our business models and our ability to be able to keep our promises. They'll have more confidence in the idea that we actually know what it is that we're talking about. We're not just pretending to. will especially have credibility with technical customers. I can tell you in my years of manufacturing, when I was working with customers, it was typically with a technical person. If it wasn't with that 66% of the executives that don't have STEM degrees or don't have engineering degrees, it was with industrial engineers and manufacturing engineers. Some of the scariest people to work with were purchasing people that had engineering backgrounds because they understood the financing side and the business side. They understood the technical side, but you will especially have more credibility with your technical customers. But most importantly, when it comes to credibility, you'll have more credibility relating to your employees. I can't tell you how many employees of industrial companies I talk to that say, the boss really doesn't understand what we do. I mean, he does a good job. He's a good leader. He's a strong leader. He runs the business well. He understands finance. He understands expenses. He understands how to control the business model, but he doesn't really know how a machining center works. He doesn't really know what fluid power is. He doesn't really know what a directional control valve is. I will tell you that those people who know the technology have a much stronger ability to relate to their individual employees. And those employees, while they won't expect that individual to be an expert on everything, at least know that they have a level of familiarity with the technology. So credibility is the first one. The next one is context. First of all, for advancing technology, as we talk about automation, as we talk about robotics, it's important for us to know where automation and robotics technology is today in order to know where it is going. As we talk about what a smart sensor or a smart device is, we should probably know what it means to have a quote dumb sensor and how we make a dumb sensor smart, what that means. What is the difference between smart technology and kind of the traditional industry 3.0 technology that we see every day in manufacturing? A context for knowing when to upgrade our equipment. This is really important as well. As technology changes, we need to understand how that technology changes, what it is that we're doing today. If I can buy an industrial robot that can sense things like friction and force and temperature and disturbances and use that data to predict future failure and order its own replacement parts, I should probably understand the base operation of that robot and what robotic safety and jogging and macros and these types of things are in order to have a context for how that technology is changing and how I need to embrace and deploy that technology and the change of technology in my manufacturing operation. Finally, a context for continuous improvement. I, like many of you, served on Kaizen teams, continuous improvement teams, lean teams whose responsibility it was to improve a process, to identify bottlenecks, to identify issues related to yield or quality or the customer experience, and then bring technology to bear on improving that experience. We get the question a lot of times when smaller companies are looking at Industry 4.0 technology and advanced manufacturing, where do I even start? The answer is to start wherever you are already doing continuous improvement and learn the Industry 4.0 technology, learn smart sensors, learn smart devices, learn data analytics, learn managed switches and unmanaged switches and ERP systems and MRP systems and how all of this data is flowing so that you can then know how and when to deploy that technology in your own continuous improvement process within the manufacturing operation. So the second C is context. The third one is connections. And what we mean by that is how does technology in one discipline affect another? How does technology changes in our machining operation or our metal fabrication operation or our welding operation? How do changes there affect changes in other areas of the business? How do changes in fluid power technology affect changes in manufacturing control technology? So we start to make these connections between the various technologies within our manufacturing plant, and that in turn makes us a better executive. So, how did I go about learning all of this stuff? The truth of the matter is that I'm proud to say that I earned 2 certifications this year from the Smart Automation Certification Alliance, both in Industry 4.0, one in basic operations and one in advanced operations. And here's how this came about. When this whole COVID thing started back in March, we were proud of the fact that we recognized really, really early on that our entire business model was going to have to pivot. We had a business model that was based on getting in front of customers, on working one-on-one with our customers, being able to walk into a high school, a community college, a technical college, a university, an industrial employer's plant, and work one-on-one with them on coming up with solutions for their industrial training, for their electromechanical, welding, automation, mechanical design programs for their engineering programs. We were an in-person business, and we had a team of people that were hand selected because they were good at building relationships with customers and providing consultative insights on how they could make their programs better. Well, come the middle of March, we recognized that that was not going to be the reality for at least a while. Economies were shutting down. Our high schools, our technical colleges, our universities were closing their doors to us. We were all social distancing. We were expected to stay away. And we had a whole team of people whose incomes and success and livelihood depended on being able to have really intimate relationships with their customers. We pivoted our business over a weekend. Literally between a Friday and a Monday, we put our heads together and said, what is this new world of work going to look like? How are we going to deploy virtual tools? How are we going to use webinars? How are we going to use other ways of reaching out to our customers and pivoting our business? But the other, and we did that well, by the way, but the other thing that I think we did a really, really good job of was saying, look, let's take this, as tragic as it is, as difficult as it is, and let's turn it into an opportunity. We have talked forever about being a company that believes in lifelong learning. We talk with all of our customers about the importance of being lifelong learners, about how as technology changes, regardless of where you are in your career, whether you're just entering the workforce or you're 2 years from retirement, these changes will affect you, and you have an obligation to your employer to remain sharp and to understand how these changes are affecting the operation, as does your employer have an obligation to you to provide resources for you to be able to continue to learn and continue to understand this technology. Our entire team earned these two certifications. They were not easy. I can tell you, especially the second one was not easy. It's been a long time since I sat for that CPA exam. And this was the first time, probably since then, that I really had to study, really had to learn something, really had to make sure that I understood the content from one end to the other before I took that content and took that knowledge and put it to work on this certification exam. So here's how all of this worked. Here's how we got to that point. Number one, I want to put this into context. Again, context is important. If you think about your average bachelor's degree, 1 hour of classroom work plus 2 hours of outside study at home, at school, in a dorm, wherever, times 15 weeks equals 1 college credit. So an hour of work in the classroom, learning theory, listening to a lecture, 2 hours of outside study for 15 weeks gets us 1 credit toward a college degree. So looking at that a little bit differently, in 3 hours a week for 15 weeks, in 45 hours, we get a credit. So it's different for everybody. Some people probably move through that a little more quickly. Some people take a little more time, but on average, it's about 45 hours of work to earn a college credit. Now, the average bachelor degree program is 120 credits. You think 15 credits per semester, 2 semesters a year, 4 years to get through it. Some people do it a little faster. A lot of people take a little bit longer, but that's 120 credits. If we multiply that by our 45 hours, we get 5,400 hours. Now, you can have that degree. You can get that degree in business or in communications or in music for that matter, and not know anything about directional control valves or solenoids or what a datum feature is. 5,400 hours, you could be working in a senior role in manufacturing if that's your pathway and that's what you found your way to with that degree, and never have any formal training on industrial technology. What if we could tack on to that 5,400 hours, just 80 hours of work? What if we could tack on 80 hours of theory, 80 hours of virtual skills, 80 hours of learning, and be able to earn those 2 credentials that I talked about earlier, be able to answer all of those interview questions with an increase of 1.5%. That's what 80 hours is as a percent of 5,400 above a bachelor's degree. We can learn all of these things. And that's what I did this summer. That's what our whole team did this summer. And we did it in a really, really interesting way. And now, if I had walked into a manufacturing interview for a senior executive role in a manufacturing company, I would be able to answer these 10 questions. And those are probably 10 of 1,000 different questions of the different disciplines, the different competencies, and the different skills that I learned this summer in the process of gaining those 2 certifications. So what are those certifications? The Smart Automation Certification Alliance was founded about 2.5 years ago by a gentleman named Jim Wall. Jim is an expert in this world of certifications, came out of the world of NIMS. If any of you know NIMS, that's where he was the executive director before retiring and then later founding the Smart Automation Certification Alliance. These are those two certifications that I earned. One on basic operations of Industry 4.0 equipment and one on advanced operations of Industry 4.0 equipment. Now, these weren't competencies that Jim came up with. He reached out to some of the more recognizable manufacturing companies on the planet. And what are coming up on your screen are those that we work with that have operations in the Midwest, and asked those companies, when it comes to basic operations in the world of Industry 4.0, what should somebody know? What should somebody like Matt Kirchner, who wants a basic understanding of basic operations, know about Industry 4.0? How about advanced operations when it comes to industrial control systems and CNC and robotic programming? What should somebody know? And those companies defined the competencies around which the Smart Automation Certification Alliance built its credentials. But it wasn't enough just to be able to sit for those exams. Somehow I needed to learn all of that stuff. And by doing that, I went through 2 courses. Each course was 40 hours apiece. Now, if somebody's a little bit faster, maybe they get through that content a little quicker than 40 hours. Somebody needs a little extra time, maybe it takes them a little bit longer. It's about the competency, it's about the skill. It's not about the time it takes for you to earn it or for you to gain it. But I sat through those 2 courses. Now, they were e-learning courses. I did them on a remote e-learning platform. I can tell you this is not your grandfather's e-learning. This is not the little VCR with the TV screen that we used to set at the end of the conference table and make everybody watch exactly the same thing. Computer grade graphics, highly, highly interactive. Knowledge checks throughout, constantly checking whether or not you are gaining the competencies that you are supposed to be gaining. Quizzes beforehand to find out your starting point. Quizzes afterwards to figure out whether you have the competencies. Self-reviews along the way. All kinds of virtual skills, building virtual electrical circuits and pneumatic circuits, programming a manufacturing operation using a programmable logic controller, but doing it all virtually, learning how to program a machining center, learning about the Cartesian coordinate system, learning about speeds and feeds and G codes and M codes, all of these things that would have made me a way better executive in the years that I was running manufacturing companies in 2 courses of 40 hours apiece. From there, because my employer is a member of the Smart Automation Certification Alliance and membership is incredibly, and I mean incredibly affordable, I can sit through as many of those certification exams as my employer will allow me to sit through. And so I went through all of that curriculum. I sat for those 2 certifications. I earned both of those certifications on the first try. So I have but one regret in going through this whole process. I have one thing that over the course of this 80 hours of learning, I guarantee you that I would have done differently. And that is, if I had to do this over again, I would have done this 20 or 25 years ago. I can tell you that the knowledge that I gained, the understanding that I have, had so many applications in Kaizen events, continuous improvement events, helping our industrial maintenance people troubleshoot problems and understanding why an order was late or understanding why a line was down, and working with a customer and understanding their technology and their manufacturing operations. The things that I learned in these 2 courses would have made me a much, much, much better senior executive with manufacturing companies. And that is why today, for as important as it is for students and learners to be earning these certifications, taking these to employers and showing employers that they have these competencies, for our incumbent workers who are already working in manufacturing, many, if not most of which will still be working in manufacturing 20 years from now, to have relevant skills as manufacturing technology changes. These certifications are really important for those 2 groups of people. They are equally important for any senior executive of any manufacturing company, any advanced manufacturing company who comes from a discipline other than manufacturing, who had an education discipline that was something other than engineering. Because I can tell you, as somebody who came to manufacturing exactly that way, that this would have been phenomenal knowledge for me to have 20 plus years ago. So when I sit down for this interview the next time, I will know the answers to these questions. If you're a senior executive in a manufacturing company, if you're heading up the business and industry arm of your community college or your technical college, if you have a similar job in a university, if you're in human resources for a large manufacturing company, can your senior executives answer questions like this? And if the answer is maybe, or if the answer is no, there is a huge opportunity for you to create executives and leaders who are more relevant to your customers and to your employers and who employees and who make better leaders.